Dear students, today discuss about very important unit 1 2 marks again and again repeated for Anna University end semester examination. So first one is what is kinematic viscosity? State its unit. Kinematic viscosity V is the ratio of dynamic viscosity to density of the fluid. V equal to mu divided by rho. Unit meter square per second. Second one question, define surface tension and capillarity. Surface tension, it is the property of a liquid surface that causes it to behave like an elastic sheet resisting an external force. Sigma equal to force divided by length. Unit Newton per meter. Newton per meter. Capillarity, it is the phenomenon of rise or fall of liquid in a small diameter tube due to surface tension. Wetting liquid, water in glass tube, liquid rises. Non-wetting liquid, mercury in glass, liquid falls. Third question, define density and specific weight. Density rho, specific weight small w or y. Density, mass per unit volume of a substance. Rho equal to mass divided by volume. Unit kg, kilogram per meter cube. Specific weight w, small w or y, weight per unit volume of a substance. W or y equal to capital W divided by V equal to rho g. Unit Newton per meter cube. Fourth question, very important, repeated 13 marks and 2 marks again and again. State the assumptions used in the derivation of Bernoulli's equation. P1 divided by W plus V2 square divided by 2G plus Z1 or Z equal to 0 or Z equal to constant. That is the Bernoulli's equation. There are two applications used in Bernoulli's equation. One is Venturi meter and another one is RPC meter. Assumptions used in the Bernoulli's equation. Fluid is ideal. Flow is steady. Flow is along a streamline. No energy losses due to friction. Gravity acts uniformly. That is the assumption for Bernoulli's equation. Then repeated problem based 2 marks. How to determine mass, density and specific volume of a liquid if 1 liter of it weighs 7 Newton. Write the relation used. Given 1 liter liquid, so find volume. 1 liter divided by 1 divided by 1000 equal to 0.001 meter cube, weight 7 Newton. Gravity G equal to 9.81 meter per second square. That is not given, but consider G equal to 9.81 meter per second square to find mass and density. First one, mass, small m equal to capital W divided by G. Already given W equal to 7, taken W equal to 7 and G equal to 9.81. M equal to 7.7 divided by 9.81 equal to 0.714 kg. M equal to 0.714 kg. Second one, density. Density rho equal to m divided by v. Already find m. Mass equal to 0.714. V equal to 0.01. So 0.714 divided by 0.01, rho equal to 714 kilogram per meter cube. A specific volume V equal to 1 divided by rho. 1 divided by 714 equal to 0.0014 meter cube per kilogram. Sixth question, what is the use of Moody's diagram? First one, what is the purpose of Moody's diagram? It is used to determine the friction factor small f in pipe flow calculations based on RE numbers. What is mean by RE? RE means Reynolds number, and another one is relative roughness, summation divided by D, capital D of the pipe. Which is used in Moody's diagram. Moody's diagram used for Darcy-Weisbach equation in head loss calculation. The seventh one, DEL. Define DEL and HCl. What is mean by DEL? DEL means total energy line and HCl means hydraulic gradient line. First one, total energy line. The total energy line represent the total head in a fluid system, which include pressure head, velocity head and elevation head. That is total energy line. And another one is hydraulic gradient line. Hydraulic gradient line represent the pressure head and elevation head only, but TEL consider velocity head. Excluding velocity head, it is always below the DEL by an amount equal to the velocity head V square divided by 2G. Eighth question, explain Hazen-Poiseuille's equation for laminar flow in a pipe and write its expression. For laminar flow of a viscous fluid in a circular pipe, a del P equal to 128 mu L Q divided by D power 4, where del P equal to pressure drop, mu equal to dynamic viscosity, L equal to length of pipe, Q equal to discharge. D equal to diameter of pipe. Pressure drop increases with velocity. Pressure drop increases with viscosity, length and flow rate decreases with diameter d power 4. Ninth question, describe the different types of minor energy losses in pipe. These losses are additional to major losses, friction, and are calculated using coefficient for each causes. The flow of water or liquid. Some losses generated or created in a pipeline. Types of losses, minor losses and major losses. Some minor losses in pipes: sudden enlargement, sudden contraction, bend and elbows, valves and fittings, pipe entries and exits. Some important minor energy losses in pipe. Last question, explain the concept of boundary layer. First of all, what is boundary layer? Define boundary layer. It is the thin region near a solid surface in which fluid velocity changes from zero at the wall, no slip condition, to free streamline. That is called boundary layer. The importance of boundary layer: causes track on objects, determine whether flow is laminar or turbulent, thickness depends on viscosity and velocity. Thank you, students.